Let's take a look at an application of exponential growth, compound interest. Okay, so let's suppose that we have this situation. We have $100 and we invest it in an account that is going to give us 8% at the end of the year. So we keep our money in there, we get 8%. Well, this $100 we're going to call the principal, and then we have our interest. So we have the amount that we put in, and then we have some interest that we earn. Okay, so 8% of the 100. So at the end of the year, we would have $108. Okay, so that's how much we made. 8% interest, just simple. At the end of the year, that's what we get. Now let's suppose that we want to do things a little differently. We don't want to compute interest once at the end of the year, just 8% of the $100. Let's suppose we want to spread that 8% over the year. Instead of 8% at the end of the year, let's do this. Let's divide that by 4 and calculate the interest 4 times a year on 2%. Okay, so we're going to compound the interest. We're going to calculate the interest. We're going to 4 times a year, but instead of 8% at the end, 2 times per quarter. Okay, so let's see how that would look. Okay, we have $100. This is the first quarter right here. We take that $100, add 2% of it, and we get $102. Okay, that's the first quarter. Now, let's look at the second quarter. Now we have $102, and I'm going to calculate 2% of that, $102. And now we get $104.04. This is the second quarter. Now let's look at the third quarter. Now we have this $104.04, and you see where this is going. We take 2% of that, add it to the $104.04, and this is the third quarter. Now finally, we're at the end. We take this $106.12, and we find its interest, 2% of that, and we get $108.24. Woo! We get 24 cents more by compounding it 4 times a year instead of just calculating the interest at the end of the year. So this is what we get when we compound it 4 times. So notice, if we just calculate the interest annually, we had $108. If we calculated it, if we spread it out over the course of the year, 2% each quarter, we got $108.24. So we would say, really, we didn't earn 8% per year. We earned 8.24%. Okay, that's by compounding it quarterly. Okay, so here, that's the idea behind compounding interest. We don't just calculate it once at the end, we kind of spread it out and we're calculating it more often. So let's suppose that you have P dollars invested in an account at an annual interest rate of R. So we're being general now. Compounded N times a year. Okay, so here's our interest per compound. We take the interest rate divided by the number of times we compound. So in the previous example, it was 8 divided by 4. 0.08 divided by 4 is what it was. Okay, so here's what we have. During the first period where we calculate, we get our principal plus I times our principal. In the previous example, it was 100 plus 100 times 0.02. Okay, but now we're not specifying how many times we compound in the year. We're just being general here to see if we can come up with some kind of formula. Okay, so we get, notice with this, I can factor out a P. See, I factored the P out, and I got 1 plus I. Now, that's the first amount. That's after our first compounding. Now, let's look at our second compounding. We take the first, the amount from here, A1, plus the interest on that. So interest times A1. See? Just like up here it was P plus PI. Well, now we don't have that amount. We don't have P in there. We have A1 in there, this amount. Notice I can factor out the A1. And now notice what A1 is. A1 is this P times 1 plus I. So I just put that right in here. And now we have P times 1 plus I squared. Now remember, I is the amount of interest per compound, the percent of interest per compounding. Okay. Okay, let's look at this third. So you can see how this goes. We have the amount from the previous plus the interest rate times the amount from the previous. Factor out the A2. You can see how we get these formulas. We do A4 and so forth. It goes this way. But you can see we kind of come up with a formula here because we're saying, okay, let's look at the nth compound. Well, we take the previous, the a n minus 1th amount, factor out the a sub n minus 1, and we get this. Okay, so this is the amount after 1 year. So I'm not specifying here how many times we compounded in the year. I'm just being general. But you can see we get a formula here. This is kind of the formula that we're going to use. So let's break it down a little bit. This is the amount after 1 year. And notice, after 1 year. Now, notice if we say, okay, well, we want a formula for several years down the line. Well, I would need to put a T on here. And notice N is the number of compounds. So in other words, it's the number of times we compounded this money, this investment. If it were 4 times a year, this would be 4. And when T is 1, this would be, well, this was calculated 4 times. So in 2 years, if N is 4, this would be 8. So we would have calculated it 8 times. But we have NT here. So this is the amount after T years, compounding, N times a year. Okay? Now, we could write it this way and just say, well, this, never mind years, we're just going to use M for the number of times it was compounded totally. So in 2 years, instead of 4 times 2, it would just be 8. See? So we could write it this way. Sometimes you'll see it written this way. So A is the amount of money that you have. P is the principal. That's the amount that you initially put into the account. R is the annual interest rate. N is the number of compounding periods. T, the number of years. And I, this thing I'm doing up here, is just going to be R divided by N. And M, sometimes you may say, well, I don't care about years. I just want to know how many times the money is compounded. I don't care about years at all. So we just say M equals NT. Okay, now let's look at what happens when you compound continuously. In other words, you can compound quarterly, 4 times a year. You can compound monthly, every month, 12 times a year. You can compound every day. You can compound every second. So what we want to do is say, well, what happens if we compound always? If our money, our interest is constantly being calculated, what does that look like? Well, remember there's this thing, E. E is this irrational number. It's, it's like pi. It goes on and on forever. Here I've got it approximated 2.71828, but it goes on forever. And just remember that. Now, also realize that e to the 0.08 is approximately 1.08328. So that's something I'm throwing out here. It seems random, but keep this in mind because I want to illustrate something. Let's just look at this formula here. And this is the formula for compounding n times a year at an 8% annual interest rate. So in other words, we're going to take this annual interest rate of 0.08, 8%, divide it by n, like early on the example was 4. I took the 0.08 divided by 4. Okay? So let's suppose we have this formula to calculate the amount of money after t years. Now notice what I can do. I can rewrite this thing this way. And notice it's the same thing. All I did was realize that, using properties of exponent, I just put the t on the outside. Okay? Now, what I'm going to do is I'm going to play around with this part in here, this part right here. Okay? So let's suppose I compound the interest once a year. Well, I get this part right here just becomes 1.08. See? I just put 1 in place of n. See? And 1 here and 1 here. Now, let's suppose I compound 10 times a year. Well, notice I just put a 10 here and a 10 here. So I'm just messing with this part inside this big parentheses, the outsidemost parentheses. I get 1.08294. Now look, this up here is 1.08328. Okay? Notice this seems like it's getting close to that. Now, let's look at this one. What if I put 100 in instead of 10? I put 100 in place of n. Well, I get 1.08325. Heck, let's go ahead and put 1,000 in there. Let's suppose we're going to compound interest 1,000 times a year. Well, I put 1,000 in place of n, and look what, dig this, 1.08238. Ah, look at this, 1.08328. So if I'm compounding interest 1,000 times a year, maybe instead of writing all of this out, this right here, maybe I could just write e to the 0.08. Maybe I could just replace this with e to the 0.08 to the t, or e to the 0.08t. Maybe I could do that. So the point is, and we could keep going with this, but the point is, as n goes to infinity, in other words, as you compound more and more and more times a year, this part right here goes to e to the r. Yeah, so that's pretty cool. So if you're talking about calculating interest continuously, here's the formula you want to deal with. The principal times e to the rt.